Welcome, students. Welcome to the fourth lecture in the series of lectures of statistics, which we are studying for CFA and FRM preparation, and also for actuarials and those who wants to pursue career in machine learning and data science. Now, if you're aware that right now we are in the descriptive statistics, and in descriptive statistics, we covered moment one in our last lecture. And in this lecture, we have to cover moment two. Now, moment two is all about dispersion in the data. Dispersion in the data. In a very simple term, it is about the spread in the data. The dispersion in the data, the spread in the data. Now, the question is, how would you measure it? The question is, how would you measure it? How you would calculate the spread in the data? So, if this is the data, if this is your data, and if the description or if moment two is all about just finding the dispersion in the data, which means spread in the data, then the range is one of the best measure because range and spread can go synonymously for data. It is the width of the data. So what you simply do, you will calculate highest and subtract with lowest. You'll simply calculate highest minus lowest. So if in example, your data is 4, 5, 6, 7, and 8, then 8 minus 4, 4 is the range of the data or the dispersion in the data. This measure, range is best measure if I'm just saying that moment 2 is all about dispersion in the data. But if I tweak the definition and say that moment 2 is about dispersion in the data, but from the center. But from the center. Now the center will change everything. Do we know how to measure or calculate the center? The answer is yes, we know that. We know that there are multiple ways through which I can calculate the center. That is mean, that is median, and that is mode. These are the three measures through which I can calculate the center in the data. So we know that. So for example, this is my data. And if I want to calculate the center, this is my center. And I could have calculated the center from any one of the measure, but I have chosen mean. The reason is mean is blue, best linear unbiased estimator, which we discussed in the previous session. So mean is blue, best linear unbiased estimator. So we are taking mean as the center, not median and mode. Now, if I have to find the dispersion in the data from the center, so this is the center and these are the different data point like x1, x2, x3, x4, x5. What I need to do, I need to find out the distances from the center. I need to find out the dispersion from the center. So how would you do? You would take this number and try to find out the distance from the center. So I would write, say, xi minus mu. Similarly, for this one, xi minus mu. For this one, xi minus mu. For this one, xi minus mu. The mu is the center that won't change, but xi is changing. That is a dispersion. And what I'm specifically interested in to find on an average dispersion in the data. What? On an average dispersion in the data, in the data, in the data from the center. So we are not interested in one data point like x1 minus mean. We are interested in the summation of all and then an average. So for example, if my data is 4, 5, 6, 7, 8, I'll first try to find out what? I'll first try to find out the center through mean. If you calculate the mean for this data point, it is going to be 6. That is my center. Now from this center, I will try to find out the distance of 4, of 5, of 6, of 7, and 8. So I will write what? 4 minus 6, 5 minus 6, 6 minus 6, 7 minus 6, 8 minus 6 upon 5. The problem is when you calculate this, the data you will get minus 2, minus 1, 0, 1, 2. And it will come to 0 upon 5. That is 0. So actually it is saying there is no dispersion in the data. There is no dispersion in the data. And if there is no dispersion in the data, now tell me there is no dispersion in the data, it means that all the data point is on the center. So all the data point is not 4, 5, 6, 7, 8. It is 6, 6, 6, 6, and 6 5 times. which is not the case actually. So what we need to do? The best is to take the modulus, to take the modulus. And if you take the modulus, this equation, which we were writing as summation of xi minus mu upon n, will become modulus of xi minus mu upon n. And we all know that is the formula for mean absolute deviation. Why it is called as mean absolute deviation? Because absolute, another term for modulus is absolute, and you're trying to find out the deviation from mean. So therefore, mean absolute deviation. Okay, mean modulus deviation. Okay, so this minus 2 will become what? 2. This minus 1 will become 1. 0 will remain 0, 1 and 2. So it is 6 upon 5. That is 1.2. What is the interpretation of 1.2? 1.2 means on an average, each data point is 1.2 deviation from the mean. So that is the dispersion in the data. Now, mean absolute deviation is doing the job properly. Everything is working fine, but only one problem. It does not cater the human emotions of risk and fear, of risk and fear. And for that, what we need to do, we have a solution. The solution is there. This is the solution. The solution is there. This is the solution. Assign higher weight for higher distances from the mean. Why? But why? More you are away from the center, more risk you have. For the time being, assume this is your universe. This is your universe. And in universe, this is your home, which is the center of your universe. If you be at your home, nobody had any concern. Nobody is afraid. Nobody had any fear, or nobody have any fear. But if you move away from your center, from your home, to the next district, to the next country, maybe the next planet, it doesn't matter, but there would be more risk that you're taking. So farther you are from the center, farther you are from the center, more risk you feel, more fear you feel. And that human emotion is not captured in mean absolute deviation. So basically, what we are saying, okay, this is the mean absolute deviation formula, but we want to assign higher weights to the higher distances. So basically, what I'm saying, when I'm subtracting 4 minus 6, okay, this is the absolute deviation from the mean. Perfect. I want to assign a weight, which is weight 1. If I'm doing 5 minus 6, I want to assign weight 2. If I'm doing 6 minus 6, I want to assign weight 3. If I'm doing 7 minus 6, I want to assign weight 4, so and so forth, right? Such a manner that higher the distance, in the absolute term, higher the distance, higher the weight. So 4 minus 6 is 2, which is greater than 5 minus 6, 1. So higher the weight of 4 minus 6 and lower the weight would be 5 minus 6, and the lowest would be the weight of 6 because it is at the center, right? At the center. And the weight should be equal for equal distances. For this, the distance is 2. For this, the distance is 2. The weight that you assigned should be equal. So therefore, weight 1 should be equal to weight 5, and weight 2 should be equal to weight 4, and weight 3 should be like negligible because you are at the center. Now, what they devise is the best way to do is just do the square. And that gave birth to the concept of variance. Why? Because your weight is the distance itself. The weight is the distance itself. So whatever the distance, that is going to be the weight. And that gave square in the mean absolute deviation formula, and that become the variance formula, the most popular variance formula that we all know. Okay, now this solved two problems. The first problem, that farther you are from the center, more weight you are assigning. The second problem is you don't have to take absolute values, as in you don't have to take modulus, because square will convert any negative value, into positive. Okay, but still there is a problem. The problem is it will make the unit of the risk or of the dispersion in the data as unit square. What it will do? So it will make the measure of dispersion, moment 2, the answer would be in unit square. So this is in unit square. How come? For example, it is 4 meter, 6, 5 meter, 6 meter, 7 meter, 8 meter. So what will do? 4 meter minus 6 meter square, 5 meter minus 6 meter square, 6 meter minus 6 meter square. At the end, whatever the answer will come, it would be in meter square. And that is very absurd concept, because what would you will understand from this meter square? So it is better to do what? Under root. And then you take the under root of variance, and which which gave birth to a formula which is square root of the summation of xi minus mu whole square divided by n. This is the formula for what? Standard deviation. This is the formula for standard deviation. And this is the best measure for moment 2. This is the best measure for moment 2. Okay. Now, few notation. If you're talking about the population, the notation of variance is sigma x square. If you're talking about sample, the unit of variance, sorry, the notation of variance is sigma x square for population, and for sample it is sx square. The formula we discussed, summation of xi minus mu whole square upon n. This is going to be the notation and formula for the variance, but formula for the variance if we are talking about population, and this is the formula for the variance if we are talking about the sample. It is xi minus x bar. X bar is sample mean. Mu is the population mean. We are talking about the sample. So x bar stands for what? Sample mean. And it is n minus 1. 1 is because of the degree of freedom, which we'll cover in another session. However, if we talk about standard deviation, then it would be under root of sigma x square, therefore sigma x. And for sample, the notation would be sx instead of under root of sx square, right? I have just taken the under root in the formula of the variance. Mu will remain the mu, n will remain the n for the population, but for the sample, it has to change to x bar and n minus 1 because of the concept of degree of freedom. So this is the measure of moments. Now, you can also solve one question like, can you find out the standard deviation for 4, 5, 6, 7, and 8? Yes, you can do that. You just subtract each entity from the center, take the square, 4 minus 6 square, 5 minus 6 square, so on and so forth. Take the summation, divide by 5. And at the end, for this example, the answer would be under root of 2, that is 1.414. Okay. Let's recap everything. We said range. Let's recap everything in a minute. We said that moment 2 is the dispersion in the data. Now, to measure the dispersion in the data, and if you are just talking about dispersion in the data, then range is one of the best measure. You don't have to do anything. It talks about the spread in the data, the dispersion in the data. But if you change the definition and say dispersion in the data from the center, range will not work at all. And the true definition of moment 2 is the dispersion in the data from the center, and it is on an average dispersion in the data from the center. So therefore, you have to calculate the center and dispersion from the center. So you could have simply do x minus mu, and if you're interested in on an average, you will do the summation upon n. This would be the formula. But the problem with this formula is that most of the time this formula is going to throw you a incorrect dispersion in the data like 0. Even there would be a dispersion in the data. And for that, what we did in this formula, we have applied the modulus. Now, this formula is the mean absolute deviation formula, working pretty good, but it doesn't capture the human emotion that farther you are from the center, more risk you are taking. So you should assign higher weights to higher distances. And for that, we have assigned higher distances, higher weight to higher distances, lower weight to lower distances. Now, what would be that weight? After looking into the different permutation and combinations of possibilities of the solution, we looked into one solution that said that if we take the weight equal to the distance, that will make the formula the square of x minus mu, or square of distances, the summation of square of distances. This is nothing but the formula for the variance. Okay, the distances are xi minus mu and square. Take the summation upon n. The square is because one of them is representing the weight. This is the formula for the variance. But the problem with the variance is that it will throw the final answer in unit square. If it is in meter, it would be meter square. If it is percentage, it would be percentage square. So to fix it, we'll take the under root, and that gave birth to the standard deviation, which is the best measure for moment 2, and it is also one of the best measure for risk in finance, because it captures the human emotion that farther you're from the center, more risk you are taking. Okay, with that we have completed moment 2. In the next session we'll cover moment